All right, this question we're going to go over number 3 from our practice exam. So they give us this piecewise linear function, and they ask us, and then they define this function g of x as the definite integral from -2 to x of f of t, where we're given the graph of f. And then part A says find g of 3. So g of 3, need to not be writing with white on white. G of 3 would be the definite integral from -2 to 3 of f of t dt. And so because it's linear, we're just adding up and subtracting different shapes. I'm going to make this a little bit bigger so we can see this picture a little clearer here. The tricky part here is that we're starting at -2. That's -2. So this little chunk right here is not a part of my area. So I got to get rid of it. But I do want everything in here. And then also we're going to 3, so that's 1, 2, 3 about there. I do want that as well. We're going from left to right, so that's nice. So the signs are what they say they should be. Above the x-axis is positive, below the x-axis is negative. So in terms of doing this, I think what I would do is I would just say, all right, well, let's find the area of this entire triangle here, and then subtract the little red chunk there. So what I would do is I would say, okay, well, that's from -3 to +2. So I've got 1/2. The base is 5. The height is 4. And it's getting a little crowded there. So that's that upper triangle, right here. That's the area of this triangle. And then I need to subtract this little guy off here. So it's going to be -1/2 of the base, which is 1, because it's from -3 to -2, times the height. Now the height is not given to us for that particular point, but if you look at this V in the given graph starts at -3. This next V point, the top of this triangle, is at 4. So my slope is up 4 over 3, which means that the height here is 4/3. And then we need to do that last little green triangle down here, which is 1/2, which is 1/2 the base, which is 1, times the height, which is -2. We've talked about it in both the other two videos. Leave it like that. No need to simplify. Maybe later I need to simplify, but for right now, just for the answer to part A, I'm just going to leave that as this expression because the expression is correct. Okay, where are we both increasing and concave up? Oh, actually, sorry. Thinking about the other version. The other version just had you go one more space. So instead of ending at 3, you ended at 4, and so you had to go all the way there. So this last triangle would have just been a little bit bigger. Part B, where are we both increasing and concave up? Well, we're increasing if the derivative is positive. So if g prime is positive, and we're concave up if g double prime is positive. Well, g prime is just f. So that being positive just means that the function is above the x-axis. G double prime would then be f prime, which means that the graph f is increasing. And so if we look at the graph here, get rid of this stuff. If we look at the graph, it's f is positive, meaning g prime is positive, all the way from -5 to 2. But then within that interval, we're only also increasing, meaning that f prime is positive from -3 to 0. So that's my interval here for part B. from -3 to 0. 0. Let's go ahead and shrink this back down. We don't need to rely on the graph as heavily here. Get rid of this guy here. Okay, they give us this function h of x, and we need its derivative. It's a quotient, so we need quotient rule. H prime of x is equal to low d high is just g prime minus high, which is g d low, which is just 5. And then square the bottom and away we go, so that's 5x squared. And now it's just plugging in. So we're plugging in 3 for x, so this first one becomes 5 times 3 is 15. Now g prime of 3, well, in the previous problem we said that g prime is f. So we just need to know what is f of 3. Well, f of 3, 1, 2, 3, is -2. How do I know it's -2? Well, look at the slope of this line. You can figure out that it's going over 1, down 2. So that would be -2 there. Now, g of 3, well, that's the answer from up here. So if we want to be really sort of taking advantage of the fact that we don't have to simplify, I'm just going to take this whole deal and put it right there, and then multiply that by 5. And then the bottom is 15 squared. And I'm not going to simplify. I wouldn't, it just feels a little weird to me to do exactly what I did there. I would actually go ahead and write this thing out right here on your AP exam just to make sure, but then I don't need to simplify. I'm just going to plug that old ugly thing in there. Now part D, I apologize, you actually can't answer this question, so I just gave everybody full credit for it. I just didn't choose my point carefully, so that's my fault. But it's nice to review anyway, so I'm going to look at it because that's what we're here for. We're reviewing for our AP exam. So here's this function p of x, and just like in the previous one, they want us to just find some derivative here. So p of x is not a quotient, but a composition where you've got this function x squared minus 3x inside of f. So that's chain rule. So p prime of x is going to be the derivative of the outside, so f prime, with the inside left in it, times the derivative of the inside, which is 2x minus 3. Now the reason you're not able to actually do this one, like I said, I didn't choose my point carefully enough. If you plug -4 in, out here, you know, you get 2 times -4 is -8, minus 3 is -11, no problem. But in here you get f prime of 16. And I just don't know what that is because f prime is based on the graph, and I don't know what happens when x is 16. So my fault, I gave you full credit, but still a question type that we want to make sure we're prepared for.